Okay, so let's get started here. So this chapter, this packet, we're going to split in half. So we're going to do the first three sections at first, and then we'll do the last couple sections in another video. So let's just start with some basic stuff here again, like we did before. So we're going to start with some area formulas, and these are all ones that should sound pretty familiar, and I'm going to draw some rough pictures with them. First theorem is the area of a rectangle is a product of its base times height. Now, we all know that. We've been doing area before, especially with rectangles. So if I draw a rectangle, obviously a rectangle is one that has the right angles. So if I call this we'll just call this base times height. So area of a rectangle, area equals base times height. Pretty straightforward. Nothing terribly difficult there. Now, the area of a parallelogram. Now, remember, rectangle is a type of parallelogram. And so, if I were to draw maybe a little bit more traditional looking parallelogram, okay, remember, parallel, 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 parallel. And so now the way you do parallelogram is, if we take a look at this here, let me blow it up just a little bit here. And so, as it says, the area of a parallelogram is a product of the base and the corresponding height. So the height, okay, well, let's do base first. So base would be this distance down here, again, so from here over to here. Now the height is the distance from the top straight down. Okay, that would be the height. You can either draw it there, or you could extend out this way, kind of like we do with triangles, and we could draw the height this way. Okay, but again, the area is base times height for a parallelogram, just like with a rectangle. Alright, let's shrink this down back again. The last one here is the area of a triangle. Okay, so area of the triangle is half the product of a base and the corresponding height. So again, if we talk about, I'll just draw a simple triangle here. I guess we'll go red. So here's our base, our height. Let's drop down from the vertex to the base you're using. That's your height. And area equals 1/2 base times height. Now the question comes up sometimes of, like, what do you do if it's kind of a funky looking triangle? So like, for instance, what if it's a triangle that looks like this? Okay, and I know this base right here. Well, here is where you can extend your base out and drop your height, and it's still 1/2 base times height equals the area. Okay, pretty straightforward. So those are all ones that you should know. Okay, you need to memorize these things, not just for our sake, but for anything that you do moving forward. You should know those sorts of things. Okay, so let's keep going. Alright, so next theorem. Area of a trapezoid is half the product of the height and the sum of the bases. So it's, whoops, let me undo that here for a second. So here it is. 1/2 height times base plus, 1/2 height times the sum of base 1 plus base 2. So if I draw my trapezoid, and we're not necessarily talking about an isosceles trapezoid, any trapezoid here, so parallel, parallel. And so again, my height, I drop it down. Okay, and if I call this up here, this base 1, this base 2, and this the height, so my area is exactly that. It's 1/2, whatever that height is, times base 1 plus base 2, just like I wrote over here. Okay? And that's true for trapezoid, isosceles trapezoid doesn't make a difference. Okay, all trapezoids. Alright, so next one, rhombus or a kite is half the product of the lengths of its diagonal. Ooh, what does that mean? Oh, there you go. So if I were to draw, let's just do a rhombus here for a second. Okay, kind of the traditional looking rhombus, where all the sides are the same. Drawing some diagonals. And we'll just call this one diagonal 1. We'll call this one diagonal 2. And so the area is exactly what we just wrote, 1/2 d1 times d2. So it's kind of interesting. You're not using base, you're not using height or anything like that for the rhombus. You're actually just going to go through and use those diagonals, which is a little unique. And the same thing exists for kite as well. You're going to do the same sort of thing. Okay. Hopefully there's no questions. Those are all pretty straightforward. Nothing really to write home about, if you will. But we're going to get into some pretty tough stuff here in just a second. So let's go through and let's talk about a couple of definitions here. First of all, regular polygon. Okay, the word regular is kind of the key part right there. A polygon whose angles are all equal and whose sides are all equal. So like for instance, if I draw, let's just pretend this drawing on my right is a regular polygon. Well, it's 6-sided, so it'd be a hexagon. So if I say it's regular, that means all the sides are the same length and all these interior angles are the same. That's what it means to be regular. Okay, is that all sides are the same and all interior angles are the same. Okay, now in a polygon we have a couple of definitions. One is radius, and you might think a radius was circle, which is true, but a radius you can call also when it regards to a polygon, and that's the distance from the center of a regular polygon to the vertex. So for instance, if I say this point right here is the center, then that right there, let me draw this a little bit bigger. So I'll draw all the radii. There's a bunch of them. Okay, so those are all, that's a radius right there. Okay, and those are all congruent, those radius right there. And the radius actually do something kind of unique in a regular polygon, in that they split the angles in half. Okay, they bisect vertices. That's important right there. Okay, this next word you might not have heard before. I've heard it said a couple different ways. I'll be honest, I don't know exactly the way it's supposed to be said. I call it an apothem, but I've heard people call it an apothem as well. And an apothem is the perpendicular distance from the center of a regular polygon to a side. So I'll draw this blue. So this goes from the center again, but this time it goes to a side, and it creates a right angle like that. Okay, and obviously every side has one. If I drew it, I could go all the way through and draw them. So lots of stuff right there. And so in the blue, that's your apothem. And the apothem also bisects the side. That's another key part right there. So it actually splits these sides in half as they go. Okay, lots of stuff there. And the last thing here is, in regular polygons, we said all the interior angles, okay, all these angles right here are all the same. But it would be helpful to know what those angle measurements are. Well, there's a way to figure what the sum of those angles are. And it's a nice little formula, and that formula goes like this. It says the interior angles, if we go by this last part right here, the interior angles of a regular polygon can be determined by the sum, which would be n minus 2 times 180 degrees. Okay, so that would be, so n meaning the number of sides. Okay, so for this one, there's 6 sides, so I would do 6 minus 2, which is 4. 4 times 180. Okay, and so that would be 720 degrees. And so each one of these angles adds up to 720 degrees. Well, how do I figure out what each angle is then? Well, I take 720 and divide it by 6. If I divide 720 by 6, I believe I get something like 120 degrees. So each one of these angles is 120 degrees. Okay. Hopefully that makes sense. You know, and you can do that, you know, a million different ways. We can do, let's actually, I'm going to add something in here. Let's say we have an object we're really familiar with. Let's say this is a square. All sides are the same. Okay, and I know we know the angles are 90 degrees each, but let's just prove it here for a second. So if I tell you this is a regular polygon, well, I can figure out what the sum of all the angles is by just doing the n minus 2 times 180. So in this case, the sides are 4, so I do 4 minus 2 times 180. So 4 minus 2 is 2. 2 times 180 is 360. So the sum of all these angles is 360. Well, there's 4 sides, so I would just divide this up by 4. So that would equal 90 degrees each one of them, which is, we already knew that, 90 degrees. Okay, so that's how you figure out the individual angles of a regular polygon. And that's really helpful and really important, because we're going to use that fact here in just a minute. Okay, so how do I figure out the area of a regular polygon? Well, this formula right here is really important. This is something that you need to make sure you know. Okay, area of a regular polygon is 1/2 A times P. A standing for the apothem, P standing for perimeter. So, if I look at this picture over here, and let's just say, here's my center, okay, and here's my apothem. Okay, and let's kind of think about this here for a second. You know, if I'm going to figure out this area right here, so I have to figure out, I'm going to do 1/2. I'll figure out whatever this length is right here. Okay, and then I'm going to figure out the perimeter. So I have to figure out all these sides, whatever these sides are right there, to figure that out. And what you're really doing right there is you're actually just going through and you're going to figure out the area of a bunch of mini triangles. Okay, not that you have to do this right now, but you're going to basically figure out the area. See how we have a bunch of little mini triangles that get created in regular polygons? And basically, if you just figure out the area of one of these triangles, then multiply that by 1, 2, 3, 4, 5, okay, in this case 5, you would get the area. Okay, and that's what this formula breaks down to be. Is basically you're just figuring out the area of a triangle and then multiplying it by 5. So area of a triangle is 1/2 base times height. Okay, so you're going to have to figure out this base right here. Apothem is the height. Okay, and that's how you figure it out. So, lucky for you, we're going to do an example. So let's start here. It says, find the area of a pentagon with an apothem of 8 and a side length of 12. Now, you don't have to draw a picture here, but let's just pretend like we're going to here for a second. Let's see how good of a drawer I am here. Okay, so there's a pentagon. And that's an awful pentagon because it's not regular. So let me try that again. Alright, let's try that one more time. There's that. Do it like this, like this. Again, let's just pretend like that's regular for a second. And so what this is saying is that we have an apothem, drops down. This is 8, and a side length is 12. Okay, so we'd figure this out. You don't have to draw the picture by any means, because we know we're just given that the formula is 1/2 A times P. Well, I know side length is 12. Since it's regular, that means actually all of these are 12. So there's 5 of them, so 12 times 5, so that's 60. So my area is going to equal 1/2 8, because that's the apothem, times the perimeter, which is 60. Alright, so go through and figure out 1/2 times 8 is 4, 4 times 60 is 240, and I think the unit is centimeters, so centimeters squared. Pretty simple in that case right there. Okay, and that's all you really have to do. Now, I'd be lying if I said that's the easiest, or probably the toughest one. Let's try one more. Okay, so this one says find the area of a regular hexagon. All right, and notice all we're given is one side. So let's just start with the basics. 1/2 a times p. Well, perimeter, let's see, these are all 18. Okay, and so we can do, let's see, we have 6 of them, so we can do that pretty quickly. 18 times 6, 48, 108. So perimeter is 108. So we know that part. Now we just need to figure out the apothem part. Well, how do we do that? Well, let's see what we can figure out. Well, what are some things we know? Let's see. We know we can figure out the sum of the interior angles. Okay, so we can do n minus 2. So there's 6 minus 2 times 180. 6 minus 2 is 4. 4 times 180 is 720 degrees. That's the interior angles, the sum. Since there's 6 of them, we can divide it up by 6, and we'll get 120 degrees. So all these angles right here are 120 degrees. Well, since we're looking for the apothem, why don't we draw it? Let's put it in here. And so this apothem, we drop that down. Okay, and one of the things I said about an apothem is that it bisects a side. So that means this is in half. And so if I were to get rid of that here for a second, and I know that this is 9 and this is 9. Now why am I doing that? Because watch this. What if I were to draw a radius down here? Well, let's see. I know that this angle right here is 120 degrees because every angle is 120 degrees. And we said a little while ago that a radius bisects the angle. So if the whole thing is 120, that means it bisects it to the point to where this angle right here, that's 60. Okay, let me blow that up a little bit here for you. So that angle is 60. Well, if this angle here is 90, this is 60, then what does this angle have to be? Well, hopefully you said 30 degrees. Alright, so let's try and see if we can remember some of these things. Remember we did those 30, 60, 90 triangles? Well, in this case, remember, if we have the ratio for a 30, 60, 90 triangle is x, 2x, and x root 3. And so if opposite the 30 was x, opposite the right angle was 2x. So if this is 9, that means this is 18. And opposite the 60-degree angles was x root 3. So this would be 9 root 3. Now, if you didn't know that, okay, you could also do one of our sine or our trig functions that we just did just not too long ago, actually the last time we talked. Okay, so we could actually do something like, since we were actually looking for this part right there, okay, and maybe I make this a little bit easier. What if I were to just kind of take this triangle that we're drawing right there and pull it over here for a second? This is 9 right there. We said this is 60. This is 30. And so since I'm looking for the apothem right there, I could also say, oh, all right, well, I know this angle. What do I have? I have opposite and adjacent, so that's tangent. So I could actually do tangent, okay, of 30 degrees equals opposite over adjacent. And I could solve that also. That's another way I could do it. Alright, so anyways, let's get back to the task at hand. So since I get a lot of stuff written here, so let me kind of just draw it over here. So I know a lot of stuff here. I know that my perimeter is 108. We figured that out up there. Alright, so 108. I know my apothem. My apothem is 9 root 3, so I can actually leave it at 9 root 3 if I want, and I'm going to, just to make life easier. If you change that to a decimal, no big deal. And so I'm just going to multiply these things. So 1/2 times 108 is 54. And then I'd multiply 54 times 9 root 3. So 54 times 9, let's see, 36, 486, I believe. Root 3, and I didn't give units, let's just say it's centimeters for argument's sake, centimeters squared. Okay, so it's not always quite as simple as the last question that I did, to where you just simply plugged in. Sometimes you actually have to figure some things out. Okay, and that's what makes some of these problems really challenging, is this part right in there, figuring some of those things out. And not all of them are 30, 60, 90 triangles. Sometimes you actually have to do the trig part to figure out what the apothem is or the side length is, whatever the case may be. Okay, that's it. That's shorter notes, but it'll actually take a little bit of time for us to get through that during class. So we're going to end right there.